Okay, let's continue our study. And in the previous class, we were just being lazy, and we gave a calculation as a homework. Do you
Yeah.
remember?
Yes. Yeah. Something about proving some
Proving a
value.
determinant, which prove that a determinant is not equal to 0.
Yeah.
Okay, and in the other day I just did that calculation by myself, and it turned out to be a very easy calculation.
Okay.
Okay,
Okay. Let's
so
start with that.
I'll share my board. And okay, can you see the board?
Wait a minute. Yeah, I can see.
Okay, this was the homework that I gave homework. Prove that this thing kn minus lm, that this term is not equal to 0.
Equal to 0.
That's
Yeah.
what we should prove in order to show that the transformation between xy to st
Was xt is transitive.
is an affine yes, is an
Yeah.
affine transformation. Okay, this is
Okay.
the transformation equations. Remember?
Yeah.
These
Yes.
are the transformation equations, and for that equations to be an affine transformation, the determinant kn over lm should not vanish.
Yeah.
Okay, so we will do that today.
Okay.
Okay, we have k. Okay, let me write here homework solution. Okay, homework solution. What was the homework? Homework was prove k n minus lm
lm
must not be 0.
that's not equal to 0. Yes.
We have k is what is k? K is, I have written in my notebook, a times small a plus b times c,
Yes.
and l equals a times small b plus b times small
Small
d,
d.
and m is c times a plus d times c, and n is c times small b and plus d times small d.
Small d. Yeah.
Okay, so kn minus lm would be
Must not
a. Okay, let's find that term. Write that product
kn
a
min
plus.
kn minus lm is equal
Okay,
to
kn. Okay, Joe, you tell me kn minus lm equals
a times small a plus b times small c times n, c times small b plus b times small d minus a times small b plus b times small d plus
times c times a plus d times c.
d times.
Okay, let's multiply. Let's
Yeah.
find the product. So a c times
A.
small b. Write the block letters,
Oh
capital
yeah.
letters initially, then
Yeah.
write the small letters.
Yeah, that will be better. A into c times a into b minus plus a d plus d
AD times AD,
a times
right?
plus bc times small bc
Okay, BC plus
plus b d capital BD times small cd minus
okay minus
a c times ab
minus again minus
minus a D times.
No, AC times
No,
BM.
A.
Oh, yeah,
No,
right. AD
times
times BC, I think.
BC,
Right?
BC minus BC times AD minus BD times CD.
CD.
Small c.
Okay. What all will get cancelled?
AC, AB cancel, gets cancelled.
Okay. Then
AD, BDC, BDCD.
okay, right. Okay, then uh, from these two terms, take capital AD common.
AD equal to, yeah, AD minus BC, you will get, isn't it?
Right.
AD minus BC plus B into C times BC minus AD.
Okay, we can write this. If we take negative common, we can write.
That,
We,
yeah,
we get AD minus BC still inside, right?
yeah,
Okay.
okay.
So from these two terms, we can take
AD minus BC common.
yes AD minus BC times what?
AD minus BC, capital AD minus BC.
AD minus BC.
Yeah,
Okay.
yes,
I wrote it.
yeah.
Okay. Now let's look back into our initial problem. Okay. We had two affine transformations. Transformation from XY to UV and
And
UV to ST.
testing.
Okay. The determinant condition of the first transformation was small AD minus BC
BC
should not
not
be
equal to
0.
0.
And for the second transformation, capital AD minus BC should not be equal to 0.
Equal to 0. Yeah.
Meaning
So
these two
these two
terms
terms
are
should not 0, non-zero.
these two terms are, we know
Non-zero.
that small AD minus BC is not equal to 0 and capital AD minus BC is also not equal to 0. Therefore, okay, I'll move
Kn minus Lm is not equal to 0.
exactly. This is not equal to 0 because this is the reason, right?
Okay. Okay.
Therefore, K Kn minus Lm is not equal to 0 and the transformation is an affine transformation.
Okay.
Therefore, the map from x comma y to s comma t, I think, right,
Yeah.
is an affine map.
Fine.
Okay, this is a really easy calculation, right?
Yeah.
We should have done it in that previous class instead of being lazy. Okay, that was a true revealing moment for our audience, I think. Okay. Okay. Now today let's do some problems regarding
Okay.
this affine transformation. Okay.
Okay.
Okay. First of all, let's look at some problems. Some problems. Let's first look at affine transformation between ellipses. Okay. First look at ellipses. Okay. First question is, I'll give you the question. You have to find. Okay. We will together. We have to find affine transformation between those two ellipses. Okay.
Okay.
First question is find the transformation. Okay, these are all finding transformation questions. Find transformations. Transformation affine transformation between first is a really easy question. X squared plus y squared equal minus 1 equals 0 or equals 1.
X square plus
Okay,
y square equal to 1.
1 to 16 u squared plus 9 b squared equals 1. Okay, this is basically a straightforward question, right? Because what will be x? What we need to substitute for x in the place of x to get 16 u squared?
For you.
Exactly. 4u and y equals
3v.
3b. Yes. Okay, this is the answer. Okay, maybe I'll write the answer.
Just scaling, right?
This is just scaling. Okay, now let's do another problem. This is also a very easy problem. X minus 1 whole squared plus y squared equals 1 to 16 u squared plus 9 v plus 2 whole squared equals 1. Joe?
Let me just check. X is equal to 4u. You can write it like that, isn't it?
No, I don't. I think x minus 1 should be right.
Oh, 1 second. What was the equation? 1 second.
X minus 1 whole squared plus y squared equals
Oh,
1.
okay. X minus 1 the whole square. Okay. So it will be x minus 1 the whole square is equal to 16 u square. From here we can take the square root. You will get x minus 1 is equal to 4u, which implies x is equal to 4u plus 1.
Right.
Similarly, y squared will be equal to 9b plus 2 the whole square. Taking the square root, y is equal to 3 into b plus 2.
Y equals 3 times
b plus 2.
v plus 2. So that's it, right?
Yeah. Changing origin and scaling. No.
Let me move it to here. Okay, these are the Affine transformations. Okay, let's do another problem. I think this is also an easy problem. Anyway, I'll write it. The equation for first ellipse is 4x squared plus y squared minus 6y plus 8 equals 0. You should be very careful while doing this. To u squared minus 4u plus v squared minus 2v plus 4 equals 0. Do you have any idea?
How will we do this?
Because these are not in the standard form.
Standard form, yeah, we have to convert
We
it
have
into
to exactly for that. Do you have any idea?
let me just check.
Can we do some algebra?
Yeah, I'm checking. Square minus 6y plus 8. 6y plus 8. Oh, okay,
we
we can.
will work it out. Do you have any idea?
I don't think so. Let me check. 4x square plus y square minus 6.
These three terms looks like we can make it into
Get into completing the square.
exactly. Okay, so we will do that.
Plus 6y 3 into 2 6. So this will be
okay. We can. Joe, tell me. 4x squared plus y squared minus 2 times 3 times
3
2
times
times.
y 3 times y plus 9 minus 1 plus hello.
Okay, 2. I write it. 2 times 3 times y.
3 plus 1 yeah, equal
2
to
times
4.
3 times y plus 9 minus 9 plus 8. Am I correct, Joe?
Yeah, I just wrote 8 as yeah, you can write
So
9.
4x squared plus y, this 9 becomes 3 squared. So we can write y minus 3 whole squared. Right, so v squared plus 3 squared minus 2 into 3 into y. Right.
Yes, plus 8 minus 9, it will be negative 1.
Yes, it will be negative 1, so it will move to the other side to get 1. So this has become a standard form.
Yeah, let me just check. 4 square
Right?
plus y minus 3 whole square is equal to 1. Yes.
Okay, now let's convert this into a standard form. Right?
Yeah. On the other side.
So this, let me write this as a LHS. Okay.
U square minus 4u.
Okay, the RHS will become u squared minus 4u plus v squared minus 2v plus 4 equals 0. Okay, you tell me what we can do here. U squared minus
4u
4u
plus 4. I just took
plus
the
4.
fourth of 4.
Okay, plus 4 and then minus 4, right? Okay,
No,
this 4 you
4.
moved it here.
Yeah.
Okay, then we have v squared
Square
minus 2v.
2v plus 1 minus 1
Right.
equal to 0.
Okay, so we get
U minus 2 the
u
whole.
plus
V
v minus
minus 1 the whole square.
equals 1.
1.
Okay, now the transformation looks easy, right?
Yeah.
Okay,
Otherwise it won't be equal, right? The RHS of both things should be the same.
yeah. Okay, Joe, what will be the transformation equations
X
look
will be
like?
equal to u over u minus 2 over 2, I think.
Yes, u minus 2. Okay. Okay, then
And
y will be
will be v plus 2.
y will be y minus 3 equals v minus 1. So y will be v minus 1 plus 3. So v minus 1 plus 3, that is v plus 2, right?
Yeah. This is pretty fun.
Okay. This is actually we can write this as 1 by 2 u minus 1 and v plus 2 also, right?
Yeah.
Okay, now let's move on to the final question in the ellipse section. It is a bit, I think it's a bit more involved.
Okay.
13x squared minus 10xy plus 13y squared minus 1 equal to 0, or this is equal to 1. 2
plus 30 y squared
4u squared plus 9v squared equals 1. Okay, have you wrote it?
Okay, 13x square minus 10xy plus 13y square equal to 1. Okay. Okay, this is a bit more involved, I think.
Because the term x, the presence of this xy terms makes the transformation complicated.
Yeah.
Okay, but it can be done because both x square and y square have the same coefficients, right?
Coefficient, yeah.
So we can.
Right.
Okay, Joe. Before that, look at these two equations. Here there is x square. There is u square. Here is y square. And here is v square. But there is no xy term there. There is no uv term there.
Yeah.
Okay, so we have to find a way to convert these xy into some kind of square term.
Yeah.
Okay.
So I can say, let's say, I'll take 13 outside there. Okay.
Okay. Right.
Then x square plus y square minus 10xy equal to 1. So what I will do here is just oh, I cannot do that like that. If I say 13x square plus y square is equal to 4u square, that won't be right. Yeah.
Here, one thing we can do is, in order to make this xy term a square, is like when we look at these
2xy.
Okay, Joe.
Yeah, we can add 2xy.
And
2xy and subtract 2xy.
okay, then the 2xy will also, and xy will also remain there.
Oh yeah. Well, let me just check. X square plus y square plus 2xy minus 12xy equal to 1. So 13 times x plus y the whole square minus 12xy is equal to 4. Then the other side, so I can write 13 into x plus y.
Okay, Joe, can you share the board?
Yeah, what I'm doing, okay, maybe. What I'm doing may be rubbish. Negative 12xy equal to v squared. So I can write root 13 times x
No,
plus.
that's really complicated. That's making it a complicated problem, I think.
Yeah, this
there
will
is
become
an easy workaround, but it is a bit more tricky.
Okay.
Okay, I'll try to explain it.
Okay,
I haven't got the fully completed answer. I haven't got the complete answer, but we will try it together. Okay.
Okay.
What are the basic binomial identities? We have a plus b.
B the whole square is equal to a square plus 2ab plus b square.
Or a squared plus b squared plus 2ab.
2ab, yeah.
Then Joe,
A minus b
equals a squared
plus b squared minus 2ab.
And also a
plus
b.
b into a minus b is equal to a square minus b square.
Exactly, a squared minus b squared. Okay, now what we can do is, okay, Joe, this is what okay, look at it, look at the problem like this. This is a product that has a power 1, right? These two things are power 1,
Yes.
right? And when we multiply those together, we get a and b with power 2.
Yes.
Okay. So what if we substitute x as a plus b and y or u plus v and y as u minus v?
Okay.
we get u plus v times u minus v equals u squared minus v squared.
U square. Yes.
That's what we want here.
Okay.
Okay. So let's try that.
Okay.
Let's we are making a try. Let's hope it works. Okay.
Okay.
Okay. So we can do x equals u plus b and y equals u minus v. So okay, I'll move it down here. Okay. So we get x times y will be u plus v times u minus v will be
U square.
u
U square minus.
exactly. So what's the term here? 10xy, right? Minus 10xy, right? So
Yeah.
minus 10xy will be, therefore minus 10xy will be minus 10
Minus 10
times,
times U square minus V square.
right?
Yes.
Also, from these two equations, we can find x squared and y squared, right? X
Yeah.
squared plus y squared will be u plus v whole squared plus u minus v
Minus
whole
V the whole
squared.
square. Yes.
Okay, we know that a plus v whole squared plus a minus v whole squared will be, these two terms will get cancelled and
And
a
yeah.
2 times a squared plus b squared, right?
Yeah.
A plus b whole squared plus a minus b whole squared equals 2 times a squared plus b squared. So u plus v whole squared plus u minus v whole
Plus V whole
squared
square.
will be 2 times
2H square. Y square.
u squared plus v squared, right?
Yes.
Therefore, we have 13 right here.
Yeah. So
13 x squared plus y squared will be 13 times 2,
of
20.
2.
When
13
we
over
multiply,
2.
no, we are
It,
multiplying both these
oh, okay. Yeah.
by
26.
13.
Yeah.
U squared plus v squared. Okay. Okay, Joe.
Yeah.
Add up
So 20, 20 26 U square plus V square.
So therefore our equation becomes 26. You're right. 26 u square. Okay, Joe. 26 u square plus v square. Then
Minus 10 U square minus V square.
all right. U square minus v squared. Is there
Equal
any
to.
term left? Equals 1. Right.
So
Okay.
26
So
U
yeah, right. 26 u squared plus
plus 26 V squared
v
minus
square.
10 U squared plus 10 V squared.
So we can add the like terms, right? 26 minus 10 becomes
16 V squared.
16 u squared.
16 U squared minus
No, not minus, plus
plus 36 is.
v squared equals 1. Okay, what was the answer? 4 u square plus 9.
Yeah.
Okay,
So
we want 4
yeah,
u square minus 9, not minus, I think, plus.
plus yeah.
Okay, plus 9 v squared equals 1. So, okay, so what if u was u by 2 and v was also v was u by 2, because if u was u by 2, when you square we get u square by 4, right?
Yeah.
When multiplied with 16 we get 4. That's what,
Yeah.
that's here, 4 is here. Similarly, instead of if
We
you
can write V by 2.
36 b squared over 4, right? Will be 9. So we can modify the transformation. What was for transformation? X equals u plus v and y equals u minus v, right?
Yeah.
To x equals
Plus
u x equals u by 2, right?
yes.
X equals u by 2 plus b.
X is equal to u plus v the whole by 2, and
Okay.
y is equal to u minus v the whole by 2.
Okay, both are the same, right? This was a bit involved. It was a bit complicated.
Yes.
But this is how you find affine transformation between both.
Yes.
Okay. Okay, I'll give you some homework questions. Okay, let me check what's the time.
It's 7:30, 5:13 here.
Okay, it's over. I initially wanted to do all the problems today
but
in one episode.
yeah, it won't be possible.
Okay, let's continue the hyperbola case and what's the other case? Parabola in the next class.
Okay.
Okay. Did you understand the final question?
Yeah, I understood.
Okay,
Actually,
we will
it's
do
like
similar problems.
it's like heuristic learning. It's like it's not heuristic. It's like how the targeting system functions. It look at the target's positions and checks the error, adjusts itself.
It's like some kind of a trial and error thing.
Trial and error, yeah.
Okay, Joe, I'll stop the recording today.
Okay.